In section 5.5, we are dividing polynomials. Our objectives are to divide a polynomial by a monomial and by a polynomial of two or more terms, as well as dividing polynomials using synthetic division. Dividing by a monomial. To divide a polynomial by a monomial, divide each term in the polynomial by the monomial and then write each quotient in lowest terms. In this example, the polynomial in the numerator, 4x cubed minus 8x squared plus 6x, is divided by a monomial, one term, 2x. To divide by a monomial, you divide each of the terms in the numerator by the denominator. To get 4x cubed, divide that by 2x, minus 8x squared, divide that by 2x, plus 6x, and divide that by 2x. And then you're going to simplify each of those terms. When we're simplifying the first term, notice the 4 and the 2 coefficients. Well, we can say 2 goes into 4 2 times, so reduce that part. And using the quotient rule, whenever you have x to the n divided by x to the m, you can subtract the exponents and minus m. So if the bases are the same, we can subtract the exponents to get 2x to the 3 minus 1, and we can write that as 2x squared as your first term. The second term is also simplified. Notice 8 can be divided by 2. 2 goes into 8 4 times, so we can write this as 4x. Since the bases are the same for the x's, we can subtract the exponents, 2 minus 1, and that will give us 4x to the first power. And the last term, 6x divided by 2x, well, 2 goes into 6 3 times, and the x in the numerator is the same as the x in the denominator, so we can write this as plus 3x to the 1 minus 1, and that's x to the 0, and x to the 0 is 1, so we can write the last term as 3. So our final answer, when we're dividing by this polynomial in the numerator divided by this monomial, is done by dividing each of those terms in the numerator by 2x. Let's try this example. Divide the polynomial in the numerator, 8y to the 5th plus 10y to the 3rd minus 6y. Divide that by 4y cubed. Dividing by a monomial, you separate this into 3 different division problems. The first term, 8y to the 5th divided by 4y to the 3rd plus 10y to the 3rd divided by 4y to the 3rd minus 6y divided by 4y to the 3rd. We're dividing each term by 4y to the 3rd and simplifying each quotient. So we have 4 in the first can go into 8 2 times, so we can write this as the coefficient of 2. Y to the 5th over y to the 3rd, you can use the quotient rule and subtract the exponents. So the first term becomes 2y to the 2nd power. And the second term, 4 does not go into 10, but we can simplify it. 2 goes into both of those. 10 over 4 can be reduced because they're both divisible by 2. So 2 goes into 4 2 times, and 2 goes into 10 5 times. So the fraction can be written as 5 over 2. The y to the 3rd in the numerator and a y to the 3rd in the denominator, that's the same thing as y to the 3 minus 3. Y to the 0 power is 1, so we can write this second term as 5 over 2. The last term can be simplified as well. 2 goes into both 4 and 6. 2 goes into 4 2 times, and 2 goes into 6 3 times. So the fraction can be written as 3 over 2. And the y terms, y to the 1st in the numerator and y to the 3rd in the denominator, we can write it as y to the 1 minus 3. Well, y to the 1 minus 3 is the same thing as y to the negative 2 power. Now suppose we want our final answer using only positive exponents. So we would have to rearrange this last term so that we can express our answer with positive exponents. So our final answer we can write as 2y squared plus 5 over 2 minus 3 over 2y to the second power. So we're able to make that exponent positive by moving it to the denominator. Now before I get into the long division of polynomials, I want to recap and look at a basic long division problem with just numbers. For example, if we wanted to find the quotient of 467 divided by 3 using a long division process, we would be able to write this as 467 with that division of 3. And the process in which we do long division with polynomials is based on the long division with numbers. So it's really good to go back and review the basic steps, and then when we do this with polynomials, we're using variables in addition to just the numbers. So the first thing we do is we look at the first term underneath the division bar, and we find out how many times does 3 go into 4. And we know that 3 goes into 4 one time, so we put the 1 above. We put the 1 above the division sign there. Now we multiply. So when we multiply the number up top by what we have in front. So 1 times 3 is 3, and then we subtract. So remember that when we're doing this with polynomials, is we are going to be multiplying whatever's up here by whatever we're dividing by, and that answer goes here, and then we're always going to subtract. That's really key to keep in mind here, is that we are subtracting. Now 4 minus 3 is 1, and then we're bringing down the 6. Now we look at the first term here. Actually, we're looking at, go back here. We're looking at the 16 here and finding out how many times does this 16, can that be divided by 3? Or how many times does 3 go into 16? And we know that answer is 5. And then we multiply. Again, think about this when you're doing this with polynomials. You're going to be multiplying 5 times 3 to get 15. And then you are subtracting. Don't forget the subtraction here. 16 minus 15 is 1. So we have the 1, and then we bring down the 7. And then again, we're looking at the 17 here and finding out how many times does 3 go into that 17. And that result is 5 times. So we're going to multiply the 5 by the 3, divided what we divided by. 5 times 3 is 15. And then again, don't forget we subtract that amount and we get 2. Now finally we end up with something that 3 does not go into. So that is our remainder. And this is our quotient. And we can write our final answer in a couple different ways. We can write it as 155 with a remainder 2, or we can write it as 155 with that remainder 2 over what we divided by. And that's something to keep in mind when we're doing this with polynomials. We'll be having variables in our expression, our final result. Dividing a polynomial by a polynomial is what we call long division. We're dividing 2x squared minus 9x plus 10 by x minus 2. We want to write the problem so that both polynomials are written in descending powers of the variables. And we divide the first term of 2x squared minus 9x plus 10 by the first term of x minus 2. This is what we call long division. There is a lot of steps involved. So we set up the division problem, and we take the first term that is in the 2x squared, and divide it by the first term here. So we can write this as on the side, we can think of this as taking 2x squared, the first term here, and dividing by the first term here, and that can be simplified into just 2x. So x goes into 2x squared, 2x times. So we put that number above the division sign. Now we're going to multiply this 2x by what we divided by. So when we multiply 2x times what we divided by here, x minus 2, you multiply 2x times x and 2x times minus 2. And the product, you can write it as this, like this as well, 2x times x minus 2 equals 2x squared minus 4x. So we're distributing that 2x to both of the terms in what we're dividing by. 2x times x is 2x squared, and 2x times minus 2 is minus 4x. Now in long division, as we did in earlier math classes, you subtract this quantity. So we write this as, we can think of this as 2x squared minus the 2x squared, and negative 9x minus a negative 4x. We are subtracting the entire quantity. And we can write, then we know that 2x squared, take away 2x squared is 0, and negative 9x minus a negative 4x is the same thing as minus 9x plus 4x. That gives us negative 5x. And then we're going to bring down that next term of plus 10. Now we look at the first term here and divide it by the first term here. So how many times does x go into negative 5x? So we're taking this negative 5x here and dividing it by the x. The first term here, dividing by the first term here. And that is simplified to negative 5. So that's why we have this negative 5 above the division sign. Now we're going to multiply negative 5 times x and negative 5 times negative 2. So that gives us negative 5x plus 10, which we write here. Now we're going to subtract the entire quantity, subtracting the entire quantity. A negative 5x minus a negative 5x, that minus a negative becomes a plus, and that's 0. And this minus a positive 10x is 10x minus 10, or I'm sorry, 10 minus 10 is 0. So the quotient is what is found when we divide the original polynomial by x minus 2. The quotient is 2x minus 5. And the way you can check your work when you're dividing by polynomials is by multiplying. So if you take 2x minus 5 and multiply by x minus 2, writing it out in this way and using the FOIL process, you'll see that you will end up with this trinomial. All right, so let's work through this example together. The first thing we want to do is make sure that our polynomial is written in descending powers. So I'll begin to rearrange the terms here, starting with the greatest exponent of x to the third. And then we write the next highest exponent. The next highest exponent should be an x to the second power. But since we don't have that, I'm going to write this as plus 0 x to the second power. And I think of that as kind of like a space filler, so that when I do my division problem, everything stays in line. And then the next greatest exponent would be minus 2x, that's to the first power, and then the first term of positive 2. We are taking this entire quantity and dividing it by x plus 1. The setup for the long division, we're going to write that division sign, and whatever we're dividing by goes out in front. Write that as x plus 1, and then what we're dividing into is x cubed plus 0x squared minus 2x and plus 2. We begin by taking the first term, x cubed, and dividing by the first term of x. And that we can write on the side. How many times does x go into x cubed? Well, when we simplify x cubed divided by x, we get x squared. So that x squared is going to go above the division sign. Now we multiply whatever is above the line, we're going to multiply by what we divided by. So we're going to take the x squared and multiply by x, and the x squared and multiply by 1. And that gives us x squared times x is x to the third. X squared times this plus 1 is plus 1 x to the second power. Now we need to subtract the entire quantity. Subtracting x cubed and if we distribute the negative and subtracting x squared, then we add the results. We get this x cubed minus this x cubed is 0x cubed. We have 0x squared minus this 1x squared, and we could write this as minus 1x squared. And then we're going to bring down the minus 2x, and you can also bring down the plus 2. Now we're going to take the first term here and also divide it by the first term here. So that looks like taking our negative 1x squared and dividing by x. Take the first term here and divide it by the first term here, and we can simplify that to negative 1x, or just negative x. We put that result here, and then we're going to be multiplying this negative x times the x and multiplying that by the 1. Negative x times x will give us negative x squared, and negative x times plus 1 gives us a negative 1x. Now we're going to subtract this entire quantity, and when you distribute the negative here, when you're subtracting a negative x squared, that's the same thing as adding an x squared, so that's going to be 0. And then the negative 2x minus a negative 1x, when you distribute that negative, those both become positive. So negative 2x plus 1x is negative 1x, and bring down the plus 2. Now we look at the first term here and divide it by the first term again. So we want to know how many times does the x here go into the negative 1x here. So divide the first term here, negative 1x, by what we're the first term of what we're dividing by. And this simplifies to negative 1. That negative 1 goes up here. Now we're going to distribute this negative 1, multiply each of those terms by negative 1, so we get negative 1 times x is negative 1x, and negative 1 times this positive 1 is negative 1. And then we're going to subtract the entire quantity, distributing the negative signs, the negative 1x minus a negative 1x, that's a negative 1x plus x, which is 0, and that negative times that negative 1, we get a positive 1, and 2 plus 1 is 3. Now this is what we call our remainder, and this is our quotient. And then we can write our answer as follows. So the final answer would be written as x squared minus x minus 1 with a remainder of 3. And the way we take care of the remainder is by writing this as plus that remainder over what we divided by in the original problem. So that would be how we write our final answer. On this slide, we are going to be going back to the example of example number 2 and showing you an alternate way of finding the quotient. We're taking 2x squared minus 9x plus 10 and dividing it by x minus 2. This is a process called synthetic division. In synthetic division, we begin with a box, and in that box we put a number that makes what we're dividing by equal to 0. What value of x, if you plug it into here, would make this equal to 0? In this case, that value is 2. So if we are dividing by x minus 2, then the number that goes in the box is a positive 2. Alternately, if we were dividing by something like an x plus 1, the number that would go in the box would be a negative 1. Now this only works when you're dividing by a linear, a binomial, an x plus or x minus a value. Now the setup here is to take the coefficients, making sure that these are written in descending powers, and write them just the coefficients without the variables. And again, this must be written in descending powers. And in our first step, we're bringing down the first coefficient, 2, below the line, and whatever that's below the line we're going to multiply by the number in the box, and that goes above the line in the next location. So the 2 here times the 2 here is 4. The result is going to be placed above the line in the next position. Now take the coefficient -9 and add our product of 4. -9 plus 4 is -5. So bring that value below the line. Again, whatever is below the line, we're going to multiply by what the number that's in the box. And that product goes above the line. So -5 times 2 is -10. And we add those together to get 0. Now in this case, we are taking originally a 2x to the second power, that power of 2, and dividing it by an x to the power of 1. So our result is going to be 1 less power. So we took out the coefficient or the variables. We're going to plug those back in to get 2x minus 5 as our final result. That is an alternate way using synthetic division. And I suggest practicing these, finishing the homework assignments for Chapter 5, and begin studying for your test.